Okay, in this video, we're going to take a look at some parallel lines that are cut by a transversal. Now, first of all, let's get some of the notation out of the way here, is that anytime that you have these arrows like that on two lines right here, we're going to say that those lines are parallel to one another, okay? And say if this was line L and line M, we could write this as the following, that line L is parallel to line M, okay? So that's a real important piece. Also, even though it doesn't put it in this particular picture here, there is also something called making a 90-degree angle when two lines meet together to form a 90-degree angle, and that would be perpendicular. And we're going to talk about that in a moment before we move on, okay? And that has its own symbol as well. So what we're going to do is that we're going to, and I'm just going to measure some of these angles, and I want to start putting all the pieces together in the next slides here. But what we can do is that we got these parallel lines, right? And this line that kind of like cuts through them is going to be called a transversal. Okay, and so therefore, if I were to go and I say I wanted to measure the angles E and F, okay, I would put this down right here, okay, and I know that I got to extend this line like so, okay, and you can see that this angle right here is going to be 40 degrees, and by going like this, and this angle right here is going to be 140 degrees, kind of like the last example, right? So what I'm going to do is that I'm going to measure the rest of these in the same vein, so you don't have to watch me slide around all these angles and whatnot. And I'm going to put all their measurements in kind of like that little corner pocket area, and then we're going to list them off to the side. So this is what it's going to look like. Okay. So there we go, and something that I want to keep in mind just from the previous videos, notice that these guys add up to 180 degrees, making them supplementary, and also notice that we got two lines that are intersecting, and they form this business of vertical angles, okay? And those marks, when you make them, the single marks denote that the angles are equal to one another, and the double marks denote that those angles are equal to one another as well. So, putting the pieces together, let's list all these angles off to the right here. Okay, and so once we list them off to the right there, notice that each one of these, okay, and we can see that all of these angles and whatnot are going to go ahead and either be 140 or 40, okay? So that's a real powerful thing, and we're going to, in the next part of this video, start to name these angles because they work in a very predictable fashion, okay? But something I do want to measure or mention about those perpendicular lines is this type of scenario where the transversal happens to make a 90-degree angle with both of those particular parallel lines, okay? And so the way that I can write that, so say if this is, I'm going to write L, M, and just call this transversal, I'm just going to call that transversal going through here T, okay? So since line L and line T make a 90-degree angle, I can say line L is perpendicular, that means makes a 90-degree angle with line T, and it looks like that line T is also perpendicular to line M, and so I would go line M is perpendicular to line T. It doesn't matter which way that you write them, the T or the M first, or the L or the T first, that just denotes them out. And so we can also write these as parallel symbols and say that line, L is parallel to line M. Okay, so we have a lot of different symbols that we're going to run across and apply. Okay, so let's take a look at what we did here in this picture, laying out all the angles, and see how we can make the connections in the next part. Okay, so using what we did, just by measuring out the angles, listing them out and whatnot, let's start. There's 4 types of angles that we want to make sure that we are we're doing out, okay? And when I say doing out, make sure that we are recognizing the name and the position of them within the diagram. So the first ones are going to be corresponding angles. And corresponding angles, I'm going to color code in the upper left-hand corner as... Okay, so there they are, and that would basically mean is that where the dots are is that, for example, angle F would correspond to angle B. All right, so that basically means is that if whether it's up top, which is going to be right here, it's going to correlate to something that is in the same position down below. Okay, and so therefore, what we can do is that we look at the bottom and we say, okay, well, what do these angles have in common? So let's look at the blue. We got a 40 and a 40, right? We got a 140 and a 140. We have a 40 and a 40. And we have a 140 and a 140. So it looks like that corresponding angles, if I were to write out what is telltale of them or what exactly are they going to go ahead and do, is that they're going to be equal to one another, okay? So corresponding angles and I'm going to abbreviate like that, are equal, oops, sorry about that, too many, equal, or I shouldn't say or, congruent. That means is that they're congruent to one another, okay? So that means is that I got 2 parallel lines, and this this transversal is going to go ahead and streak through there like that. I know that all those angles that correspond are going to be congruent, okay? So let's take a look at another type of angle here. Okay. So these type of angles right here, these are going to be called alternate interior angles. And when we think of interior, think of the 2 parallel lines and say, just like in an interior design, that means the inside of a place, okay? So on the inside of these, like that's a long hallway right there, that's where they exist, all right? And they're on alternate sides. That means is that they're on different sides right here of the transversal, okay? And so we have these 2 guys right here, and then we have these 2 guys. I'm going to use these marks here because you see them in all different ways. And that basically means is that those are going to be congruent to one another, because if we look, we have 40 here and 40 here, which are going to match the blue angles right here and here. And we have 140 here and 140 here, which matches, oops, the blue angles, or the purple angles right here and here. So therefore, we can say that those angles are also going to be, let's see, equal and congruent, okay? So, oops, I did a cut and paste here and it kind of turned out bad for me. But anyhow, you get the point, is that they are going to be equal to one another. And one of the things that we take away before we move on to the next 2 is that these vocabulary words, we want to go ahead and be able to visualize what they look like in our head, okay? Because they're so important moving forward to proving out different properties geometrically, okay? So let's take a look at the last 2, and then we'll move on to some examples of how we'll use these. Okay, these last 2 are going to go ahead and be, this next one is going to be a play on the one that we, the angle relationship that we just discovered, and it's going to be called the alternate exterior. Okay, and so for alternate exterior, what we're looking at is, just like we said, this would be the interior of the parallel lines. We're looking at the exterior of the parallel lines. So when we label these out, I'm going to get these two angles right here, and these two angles right here are alternate exteriors. And if we look, much like we've been discovering, these are congruent, and these are congruent as well. So once more, is that their properties is that they are equal, congruent. Okay, that means the exact same thing. Just means is that they're either going to have the same, they're going to have the same measure as one another. Okay, so that leaves us to the last one, which are going to be these two guys right here. And these guys are referred to as same side interior or consecutive angles. And basically, what is their secret power is that they add to 180 degrees. So if we look at this side right here, we know that we got 40 degrees and 140, and those are going to add to 180. And just like those guys right there, they are going to add to 180 degrees. And so the vocabulary word is that we can also use is that they are supplementary. All right. And so we got lots of good information here. And what we're going to do is that we're going to take some of these and take a look at some different examples and how to apply them take a look at these properties and apply them to the examples, I should say, and see how we can make this work for us moving forward in our trigonometric adventures. So I'll see you in that next video.